from the homework, number 23, we got log base b of 3 equals 1/2. So this one's weird because we really, I don't think in class did one yesterday where our variable was in the base. But we're going to kind of do the same thing. We can't solve for it while it's right here. So to get rid of the log, we got to do b to the power on both sides. So it's going to cancel over here, and I'll get a 3. And I'll get b to the 1/2. So, how do I get rid of a 1/2 power? First of all, does anybody know another way we could write that 1/2 power? Because if it was written a different way, you would know what to do pretty easily, I think. It is the square root. Did any of you, did somebody who did not have Math 3 last semester know that b to the 1/2 equals the square root of b? I think this was something last semester that I did this real quick, and everybody was like looking at me cross-eyed because they had not seen it before. So here is where my 10th graders are going to have major advantage because they had this last semester. So if you have, so if that was a square root, you probably wouldn't know just square both sides. So if you have a fractional exponent, so if you have x to the a over b power, then that is the same as the square, or the b root of x to the a power. Okay, so like if I have x to the 1/2, then the top number goes on the inside. The bottom number is the base or the root. I always, when I think about these, I think the root, which is the number that's on the outside, it's on the bottom of the tree, so the root has to be the bottom of the fraction. So we don't usually write a 2 right here for square root, so this would just be the square root of x. So if I had something like x to the 3/5, it would be, the 5 is on the bottom, so it's the root, it goes on the outside. X to the 3rd would be on the inside. So this is just like having a square root right here. So we can just square both sides, and we'll get 9 for our answer there. Another thing, even if you're not thinking of fractional exponents, so just to throw this in right here, because this is probably somewhere we need a little more work with. Like this is totally different, but let's say we've got 7 equals x to the 3/4 power. I could change it to a root, or whenever I have something like this, if I have like a to the 3rd power raised to the 2nd power, what do I do with those exponents when I'm raising a power to a power? What? Multiply. It would be x to the 6th. If I'm doing this, a to the 3rd times a to the 2, if I'm just multiplying those, I would add the exponents. It'd be a to the 5th. But if I'm doing power to power, I multiply the exponents. So instead of even having to deal with like changing this to a root, another thing that you can just do, if I flip this fraction here, if I raise it to the reciprocal, right? Raise it to the 4/3. I should multiply those exponents, right? So if I do 3/4 times 4/3, that's going to be 12 over 12, which is just 1, right? So this just gives me x to the 1st power here, and then I could type in the calculator. Let me close that calculator. That one's too powerful for you guys. 7 to the 4/3 and get 13.391 there. So we'll try to do a warm-up or something again with fractional exponents to give you guys a little more experience with that, because I noticed last semester that was a red flag that we came to that nobody had seen before, but we can fix that pretty easily. Okay, other questions from the homework? Thank you for asking for that one, Blaine. I've forgotten about that one being on there. anything else you guys had trouble with? Any others? You guys already know it all, or just shy and don't want to ask? Don't be afraid. 32, okay. Alright, so for 32, we got 9 to the 2m equals 27. Alright, so what would we do first on this one? Log base 9. So we got 2m is log base 9 of 27. All right, at this point, I'd probably type that into my calculator. You don't have to, but it's easier. I think it's easier to type in if you do it like one step at a time. So log 27, make sure you close that parentheses over log 9, not 99, is going to give us 1.5. So we got 2m equals 1.5. And then last step here, you're just going to divide by that 2. And so half of that is going to be 0.75. Was it just calculator that had got you on that? And just leave it. Okay, yeah. Sometimes when you do a step like that, you forget to finish it out. Yeah. Okay. Other questions? 33. Which 33? Because I think there's two 33s. Is it the 42 to the x squared or the natural log of x? Okay. So for 33, we have 42 to the x squared equals 84. And so, what is the first thing that we would do for this one, Jackson? So we have this stuff up here in the top. You can't get to it while it's in the exponent. So the first thing you actually need to deal with is that 42. And since it's the base of something being raised to an exponent, we want to do the log 42 first. So sometimes it might be a little confusing, but if something is in an exponent, you can't get to it yet. You're going to have to use a log to get rid of that base. So we'll do log 42 of both sides, and that will cancel out our 42, leaving us just the x squared here. And so if we do, to do this part, we can just do log 84 divided by log 42, and it's going to give us 1.1854. Keep that number in your calculator. So you'll do that first. Then you just have the x squared. So how do we get rid of the square? Not square, but can you draw it? It's square root. Right, so square root is what we need to do. That square root will be the opposite of our square. Sometimes students forget what it is, but they can do this for me. So if you square root this, do you guys know how to do this in the calculator? Just do second and a negative key to get the answer from the line before. Have you guys seen that? Some of you know. Okay. Some of you, yes. So just do like it. Sometimes you can do the answer just by doing like +7 and it shows up, but you can't with the square root because you got to do the square root first. So when you do second square root, do second negative, and it'll put the answer from the line before, so you don't have to try to type the whole thing in. Plus, it's more precise because it actually has more decimals than you can see there. So it's the best thing to do here, and we get 1.089. For that. Hopefully that's what I have. I rounded that to 1.1 for some reason. And I do not know why I did that. Also, I had forgotten something critical on this. Here, when we square root both sides of the equation, there is something we're supposed to put with our answer. Does anybody know what that is? The plus or minus sign, which I failed to put there. So when you square root both sides of an equation, let me give you a much easier one. X squared equals 25. All right. Clearly, square root both sides, x equals 5, because 5 squared is 25. But what else squared would also give you 25? Negative 5. So whenever you square root both sides of the equation, you're supposed to put a plus or minus with your answer. In this case, because it's an exponential, it would be fine to have that negative right there. You're squaring it anyway, so it's going to become positive again. So it really should be the plus or minus. This reminds me that I need to tell you about an extra credit opportunity that my classes are getting into pretty good here. So your late work and bathroom passes are worth a point apiece. Now the difference, Math 1, if they get one, they just use it to go to the bathroom. You would be appalled to know that some kids get to the end of the quarter with no late work or bathroom passes to turn in. They've used them all. Some of them have traded all their late work passes for bathroom passes so they could go to the bathroom 6 times a semester. My other classes are usually appalled at the fact that someone would give up extra credit points that easily. But here's an extra credit opportunity for you. If you find a mistake, like this would have counted if anybody had found this mistake. If you find a mistake on any answer key that I have put out there, on a test or a quiz that doesn't have like a right answer choice, or maybe is missing information, or there's something that you need else there, you are the first person to alert me to this error, then I will give you a late work or bathroom pass. So if you're like doing the homework and you're like, oh, she didn't put a plus or minus sign there, I think it should be there, just send me an email real quick so you can be the first one. And you might be wrong, and I'll just let you know, oh, no, actually it is supposed to be like that. Or you might be right and you'll get a late work or bathroom pass. You don't have to email me and tell me in class. It's just if you wait till the next day, somebody might have beaten you to it. So be on the lookout for errors, because it is good for you to watch out for me making those mistakes because you're thinking about it. It's also good for me because it means I fix my mistakes, so there's fewer of them out there for to confuse you. So that is an extra credit opportunity. Be on the lookout. I will tell you, this does not apply to whenever I just make mistakes on notes, because that happens way too often, and I would have to have a factory print my bathroom passes to give those out. So it does not apply to just like, oh, that should have been negative, like when we're going over notes. It's only like things I put on Canvas or answer keys or something like that. It does not apply to answer keys that I did not make, or like if we do like a quizzes game or something that I didn't actually come up with. It was a different teacher, because I found that there's too many mistakes in those sometimes. So it does not apply to those. It does not apply to spelling errors. Thomas McComb has really wanted me to start including that, because apparently my spelling is not so great. Spelling and grammar errors do not apply, mostly because I don't want to run out of bathroom passes. I try to do my best, but sometimes I'm just running through things too quickly. So like small typos don't count unless the typo affects like the problem. So if I spelled a word wrong, or if I, left a word out, but you can still pretty much tell what it means, then it doesn't count. But if I leave out information, or something like my typo actually affects how you do the problem, then that can still count. So be on the lookout for mistakes, because that could get you some late work and bathroom passes. I have had to give up more bathroom and late work passes than I would like to admit since I enacted this policy. But I definitely make some mistakes sometimes, so be on the lookout for those. Okay? All right. Any other questions from homework? All right. All right, so today we are going to be looking at properties of logs. And these properties, we're mostly going to focus on expanding and condensing logarithmic expressions today. But that practice is going to be important for being able to solve logarithmic equations in the next section. Our first property is called the product property. And what it tells us is that if we have log of two quantities that are multiplied together, we can split those up as separate logs with a plus sign in between. So we will work on expanding, taking something and breaking it apart, and also simplifying, putting it back together. There are times when both of those can be helpful. So to expand here, since I've got 4 times x, I would just write this as log base 3 of 4 plus log base 3 of x. Okay, for the second one it says to simplify, so we're putting things together. So we have addition between these, which means we're going to change it to multiplication. In order to do this, you have to have the same bases. Anything I give you should have the same bases, because otherwise we're not going to know how to do it. So if you see something that's not the same base, it's probably a typo. So log base 7 of 9 times 8, which of course we could write as log base 7 of 72. You don't necessarily have to write that intermediate step. You will find, I know that some of you will probably write out every single step of everything you do. It really helps you keep organized if you do every little step. So you might would want to write this right here. Others of you are like, I will do this all in my head and write down as little as possible. I can live with that if you're the second person, as long as you're getting the answers right. There will be a few things that we go over where I've got to see a little bit of work. There'll also be times when I say you've got to show a little bit of work, mostly because I don't want you grabbing your phone and going through and just going, click, photomath 7, click, photomath 2.5831. Because I know that, especially on this logarithm stuff, it will work really well. Photomath, you wouldn't have to do anything if you just photomathed everything here. But if you don't show every step, that's okay. All right, let's look at the next property, which is our quotient property. Our quotient property is really similar to the product property, except for division is going to be separated by a minus sign whenever we break it apart. So what we would do here for this natural log of 4x over 7, it's asked us to expand. We are going to break natural log of the top part minus natural log of the bottom part. So we will have natural log of 4x minus natural log of 7. Now, this particular problem could be broken up further because I have natural log of 4 times x. So natural log of 4 times x can be broken apart. It is a good idea, since I have already broken this part up, it is a good idea to use some brackets or another set of parentheses to say natural log of 4 plus natural log of x minus natural log of 7 there, just to show that those two go together and should be done before the minus natural log of 7. Now, in this particular case, it does not matter, because do those parentheses really do anything, or brackets? If they weren't there, you'd still do natural log of 4 plus natural log of x first. So in this particular case, you don't have to have the brackets, but there will be cases where the brackets have to be there. So it doesn't hurt just to go ahead and put them there. And if you want to use parentheses instead of brackets, that's fine also. There, but it doesn't hurt to have them. For any questions on 3? All right, for 4, we've got subtraction. We're asked to simplify, so we're going to put these together. So we've got log of 9 divided by 3. And, of course, 9 divided by 3 is just 3, so we just get log of 3. Okay, questions? All right. Okay. The next one is our power property. And I can't remember who it was, but I think yesterday somebody was trying to use the power property on those equations that we were doing, but we couldn't use it yet because it was like an exponential. It didn't apply to the situation, but I knew you were in the right ballpark. So the power property just tells us if we've got something raised to a power, we can pull that power out front as our coefficient, right? So if we have a problem like example 5, the first thing we want to deal with is this exponent. We can't break 4x up until we pull that 3 out front. So this 3, we can pull it out front and just make it 3 log base 3 of 4x. Now, here's a place that our extra parentheses or our brackets are going to matter. Because we can break 4x apart, but this 3 needs to be multiplied by the whole thing. So right here, if I'm going to break it up further, I need to have a set of parentheses or brackets here showing that 3 needs to be multiplied by all this stuff here. So I will have log base 3 of 4 plus log base 3 of x. So here's a case where it is required to have those parentheses or brackets there. Which is why I say it's probably just best practice if you break something up and then you're breaking it up again, just go ahead and put the parentheses. It can't hurt for them to be there even if they're unnecessary. Okay, questions on 5? All right, 6. Here we've got these coefficients here and we're asked to simplify. So we're going to pull them back in as exponents. So we will have log base 2 of x squared plus log base 2 of 4 squared. I'm sorry, not 4 squared. That was 3. See why I can't give you a bathroom pass if I just make dumb mistakes like that. I'd run out of bathroom passes by the end of the class period. So, 4 to the third is 64. So, this is log base 2 of x squared plus log base 2 of 64. And then I can put those together because I've got that plus sign. What operation do I use when there's a plus sign and I'm combining? Addition. So it'll be log base 2 of 64 x squared. I don't know why it puts these marks here whenever I draw this, but it does. It's probably because I should be doing all this in a newer program, but it would take me untold hours to take all of my notes and change them at this point for 3 different classes. All right, any questions? All right, we really did this yesterday. The quality property of logs tells us if we have log base b of m equals log base b of n, then we could just do b to the power on both sides, which is just going to drop both of those logarithms, right? So this is where you just drop the logs. So I've given you this problem here, which is a little different than what you saw yesterday because you didn't know any product properties, right? Or you didn't know any properties of logs. So yesterday you could not have done this problem unless you just remember more from, but based on what I had taught you, you could not do this problem because you got this 2 on the outside. Okay? So since you have that 2 on the outside, you could not just drop the logarithms at the very beginning of this problem. Okay? You have got to get this 2 on the inside of the logarithm first, then you can drop the logarithms. So this we could pull in as our exponent here. So a little further over there. So we would have log base 3 of 4x equals log base 3 of x plus 1 squared. And now, everything on the left side is inside of our logarithm. Everything on the right side is inside of our logarithm. So we could just drop those logarithms. Essentially, what you're doing is you're doing 3 to that power on both sides, which cancels those logarithms out. So, now we got 4x equals x plus 1 squared. So, what do we do here? We got that square we're going to have to deal with. Any ideas of what we should do with it? What do you think, Hallie? Perfect. Very good. There's several things you might want to try to do with this. You might think of like trying to square root both sides. The problem with that is if this was just a 4, that'd be a great thing to do. But the problem is over here you're going to get square root of 4x. There's an x under your square root. You're not really getting anywhere. So you can't square root both sides. So Hallie said that I need to multiply this together. And I love the way she said it. She said you got to do x plus 1 times x plus 1. Because a lot of students want to say that this equals x squared plus 1. However, it does not equal x squared plus 1. We have to do x plus 1 times x plus 1, right? And we have to distribute here x squared plus x plus x plus 1 x squared plus 2x plus 1. Okay, so right here we're going to have 4x equals x squared plus 2x plus 1. Now, at this point in your math career, I prefer that you don't have to write this over to the side. You should be able to square that in your head, but I'm not sure if you've been taught how to square it in your head or not. You may have just figured it out on your own. So what I always teach students is I call it you square double square. You square the first number, so that gives you your x squared. Then you multiply these two together here, you get 1x, and you double it. So 1x times 2 gives you 2x. And then you square the last, which is just that 1 there. We'll practice a little with square, double square, because what you're going to find is this is something we're going to have to do pretty often in this class, but there's going to be like tons of other steps after it. So rather than having to do it this way where it takes you 3 steps and then you got tons of other stuff to do after that, if you can do it all in one step, it makes the problem seem a little less, scary whenever you're looking at it. So we'll practice with that a little bit. We want to work to where we can automatically just do x squared plus 2x plus 1 from there. Some of you probably can already. Some of you might need some practice with that. So this is like what we were doing for the warm-up. We have an x squared, but we also have x's. So this is a quadratic. So for a quadratic, you're going to need to move everything to one side. So we're going to subtract this 4x. And so we get 0 equals x squared minus 2x plus 1. And a lot of times I'm going to give you something that will factor. Sometimes it will not. In this case, it will. We could have x minus 1 times x minus 1. That would give us the negative 2x in the middle, but a positive 1 on the end. And then so we would set each one of those equal to 0. So since it's the same one, you don't want to have to do that. So we end up with x equals 1 for that. We should always kind of check to plug that back in. It's fine to plug 1 in here. 4 times 1 is 4. 1 plus 1 is 2, just to make sure we're not getting negative numbers inside of our logs, or 0. Okay, questions? All right, so your assignment today is going to be on Delta Math. So I pulled some extra ones from Delta Math just to give us a little practice with like what you're going to see there, because they use a lot more variables than I have used in the first examples. So the question is going to basically have one of these two instructions for the most part. So if it says condense the logarithm, you're trying to put it all back together. So the first thing you would want to do is pull in your exponents here. So we would have log of b to the 8th minus log of d to the q. And then I've got minus between. What is that going to become whenever we condense? What operation do we use there? Divide. So we will have log of b to the 8th over d to the q power. And that is what you're going to type in your Delta Math. All right. This is another way that they will also ask you to condense. It says write the expression below as a single logarithm in simplest form. So it wants you to combine here. There's nothing separated. We just have this exponent here. So we would have log base b of 5 to the 3rd power. And I believe when it says in simplest form, it means don't leave those exponents like that. So you would have log base b of 5 to the 3rd. So 5 times 5 times 5 is going to give us 125. And for the most part, I'm pretty sure on this first test, it's all calculator active. So I encourage you to do things like 5 to the 3rd in your head, just because it's good mental exercise, but you will have a calculator for everything here. Okay, you'll also have some that are expanding logarithms, and the tricky thing about this is you're going to have to make sure you expand completely. If you do not expand completely, it will not count it right. So if we look at example 10, we've got log of x to the 4th over y to the 2nd. So when I see that division, I'm going to break it up using subtraction. So that would look like this, log of x to the 4th minus log of y squared. And what I find is students sometimes type this answer in. And it is equivalent to the original, but it's not expanded completely because you still have these exponents that you could take out. So we want to take those exponents out and make them coefficients. So we would have 4 log x minus 2 log y. All right, our next one is a little bit more complicated because we've got more stuff, but we would still break up that division with subtraction. So we would have log of x cubed y squared minus log of z to the 4th I want to break up this multiplication with addition first. So I've got log of x to the third plus log of y squared. Here's another example. It's not really required to have those parentheses there, but they're not going to hurt anything if you put them. There might be some cases where you got to have them, so I would just go ahead and put them. And then we've got all these exponents here that need to be pulled out. So we would have 3 log x plus 2 log y minus 4 log z. Questions here? Okay. All right. Here is our last thing that we are going to see. And these are sort of the trickiest ones. Here, we've got to find the numerical value of the log expression. We've got log A equals 5, log B equals -4, and log C equals -11. This does not mean A equals 5, B equals -4, and C equals -11. So we can't just like plug those numbers in to what we've got here and then type it in the calculator. What we're going to have to do is we're going to have to break this all apart. And once we break it all apart, then we can replace log A with 5, replace log B with -4, and replace log C with -11. So these are going to require you to expand first. Here is, well, the first thing that you're going to do is you got that division, so you're going to break it up with subtraction. So you'll have log base, or log of the square root of b to the third minus log of a to the 7th, c to the 7th. Now, the square root of b to the third is we're going to have to know how to do what Blaine was asking about on that question from the homework. Because I didn't give you any property that dealt with the square root, right? So what we need to do is we need to change this to a fractional exponent, okay? So there is no number out here, but this is a square root. If there's no number, it's a square root. So it's got a little invisible 2 out here. So to write this as a fractional exponent, we can write it as b to the 3 over 2. So this is equivalent to b to the 3 halves. Now, fractional exponents just fall under our product property, power property, where we can just pull that exponent out. It doesn't matter if it's a fraction or not. You can just pull that exponent out now. So we're good to go with that. Right here, we can break a to the 7th, c to the 7th up with addition. But you must have parentheses here. So make sure you put that log of a to the 7th plus log of c to the 7th. You got to have those parentheses because this minus sign applies to both of these. So you're either going to need the parentheses or you got to distribute that negative to both of them there. And so now, last thing, our exponents can go out front. So we'll have 3 halves log b minus 7 log a plus 7 log c. And so by expanding, we have made it where we've got just the plain log b, the plain log a, and the plain log c. we can now plug in these numbers that were given to us for those. So we got 3/2 times -4 minus 7 times 5 plus 7 times -11. I'm going to run out of room up here, so I'm going to go up here. So, everybody remember how to multiply fractions? Remind me. If I've got -4, it's like -4 over 1. What do we do when we multiply fractions? Straight across, right? So this would be -12 over 2, which is -6. I often find, although we should know that really easily, that sometimes fractions are not our strongest, even with my honors crowd. So 3/2 times -4 gives you -6. Then 7 times 5 is 35. 7 times -11 is going to give us -77. So we got -6 minus 35 minus 77 is going to give us -42. Doing that right? I think so. You can check me with your calculator if you want. And then negative and negative here becomes positive. And so we end up with 36 for our answer. I'll double check me with those calculators. You can type the whole thing into the calculator if you want. I encourage you, just for your own mental exercise, to try to do these without the calculator. If you can run through it pretty quick, don't sit here and try to do like 297 times 14 without a calculator. That's what the calculator is for. Don't, there's not necessarily value in that, but stuff like this, try to do it without a calculator because it'll make you better at math in general. But if you must, you can grab it. Okay? All right, that's our last one. No. Hold on. Okay, that's our last page. Okay. All right, so also, let's see, do I even want to do this right now? We'll go ahead. I don't think homework gets into this very much, but I want to just look at it really quickly. This just goes into a few equations with this, which I can't remember. I did all of my planning for all of this before Christmas, so I'll glance back over it, but I can't remember if I put these on Delta Math or not. I don't think I did. We'll see. Right now, I cannot drop the logarithms for this problem, because in order for us to be able to drop the logarithms, in order for us to use that property where we can just drop the logarithms, I've got to be able to do 12 to the power over here and 12 to the power over here. Well, if I do that, I got to do 12 to all that big expression, and you don't have your 12 right next to your log 12. All right? So, in order for me to solve this, I am going to have to combine everything over here on the right-hand side first, then I can drop the logarithms. So, that's going to look like this. The 1/2 can go in as an exponent. The 1/3 can go in as an exponent. Okay? So, I've got log base 12 of x equals log base 12 of 9 to the 1/2 plus log base 12 of 27 to the 1/3. Ooh, here we got those fractional exponents again. They keep popping up, right? So when I've got 9 to the 1/2, that is the bottom of the fraction is your root. The 9 is going to be to the top of the fraction, first power. This is really just the square root of 9. Square root of 9 is 3. right? So this is going to be, especially that part right there, I want you to do it without your calculator because that's something we're going to need to know. I've got 27 to the 1/3. The bottom of the fraction is my root. The top of the fraction is my exponent. So when I see something to the 1/3, that's just the cube root of 27. What is the cube root of 27? What is 3, right? Log base 12 of 3 also here. So when I put this together, I'm going to have log base 12 of x equals log base 12 of 3 times 3, which will give me 9. And then at this point, now everything's inside of a single logarithm on either side. So I can just drop logarithms and x equals 9. All right, questions? All right, our very last one here, I think it's actually probably a little bit easier than 13 because it doesn't have any of those roots. So here, we need to combine these. We got a plus sign. That's just going to be log base 6 of 9 times x equals log base 6 of 54. And so, same logs on both sides. Now everything's inside of both of those logarithms. We can do 6 to the power on each side, which is just going to drop our logarithms. 9x equals 54. So we divide by 9 on both sides, and x is going to equal 6 for that. Okay, any questions? All right, so your assignment is going to be on Delta Math, and perhaps, good gracious, I've got 10 emails during this class period. Perhaps our best bet for getting you guys should have been into Delta Math before, but you're not in my class yet. So I think the best thing to do is if you go to Canvas for today's assignment, I think if you just click on this link, it's going to like add you to my class automatically and you don't have to put in a code. But let's see how that works because that's a new feature in Delta Math and I'm not sure that it's working. And so you will work on this assignment for properties of logs. It's called Homework 1.2 Properties of Logs. Delta Math I love for some topics because it gives you a lot of different problems and it tells you if you're right or not after every problem. However, there may be times where maybe you're having some trouble with Delta Math and it's just not working for you. Maybe you have tried and tried and tried. It gives you, we've got the upgraded version, so most of the topics have help videos for them. You can watch the videos and all of those things. So, in general, when I give you a Delta Math assignment, it is never my intention to give you 3 hours of homework in this class. Some nights will have more than others, but you should never have 3 hours of homework from me. So if you are doing Delta Math, and it is taking you forever and you're not making progress, Delta Math shows me how long you've spent on it, how many questions you have answered. It shows me whether or not you have, watched the videos. So if I see that you spent 45 minutes, you watched the videos, you answered 17 questions, you just weren't getting anywhere on it, then I will give you credit for the assignment for those. So here it says complete this assignment or spend at least 35 minutes. Now, I will say this. I'm not exactly sure how Delta tallies your time. So, if you, like, set the timer and spend 35 minutes, but get up and go to the bathroom for a second and it's paused, you know, like, you're not actually doing anything for a minute, I'm not sure if it's going to give you 35 minutes worth of credit. You might work a little more than 35 minutes, but make sure it's obvious that you have put forth an effort. Sometimes in the Math 1 class, or, you know, it's usually them, it's usually not you guys, but they're like, Miss Hyatt, I just couldn't do that homework. And I look at Delta Math, and they did 2 questions, and it took them 3 minutes, and then they quit. So that's not going to get you anywhere. But I think you should probably be able to do this in 35 minutes, but if you're super stuck, then just know that I don't want you to spend 3 hours on it. And we have about 20 minutes to work on it here, so we'll do that right now. Did you guys click on the link and it added you to my class? It's working. Caitlin says it's working for her, so hopefully it will for